So let me discuss about for 3 by 3 matrix. So let the matrix E of order 3 by 3 and the entries are A11, A12, A13, okay, and A21, A22, and A23, A31, A32, A33. Let us take this 3 by 3 matrix. Okay, so principal minus. So first let me construct for 1 by 1 order. So principal minus of order minus of order 1 by 1. So how many such principal minus exist here? So by deleting, okay, by deleting 2 rows and 2 columns, 2 rows and 2 columns, we will get, okay, get the principal minus. We will get the 1 by 1 principal minus, 1 by 1 order principal minus. Okay. Principal minus. So now you delete every time 2 rows and 2 columns. So in the last class what I said is 1 by 1 means I have taken A11, det of A11 and A12, A13, A1, A21, A22, A23, A31, A32, A33. All these entries I have taken, but it is not correct. You have to take like this. So you have to delete any 2 rows and 2 columns. For example, I am deleting these 2 rows. Look at, so these 2 columns I am deleting. Indirectly second column, third column. Simultaneously second row, third row. Second column, third column, second row, third row like that. So what you will get? A11 you will get. Therefore the principal minus are A11. So that I'm denoting with so P1, that means first order principal minus A11. So determinant of A11. Next one, the 1 by 1 principal minus. So now by deleting second row, second column, third row, third column, like this you are getting. Similarly, you delete, so second and third is over. Okay, second and third is over. Next, first and second you take, first and second. So first row, second row, first second you are taking, right? So first column, second column simultaneously. First and second rows and columns you are removing, then you are getting A33. So therefore A33. Okay. Next, similarly, P1. Is there any possibility? So now first and second is over. Next one, what is left? First and third is left. All the combinations you have to take, right? Next one, first row, third row. Simultaneously first column, third column you have to eliminate. Then what remains? A22. So therefore here what I need to write? A22. That's it. So only you need to check the diagonal entries only. A11, A22, A33. That's it. Not all the single entries. So this is about principal minus of order 1 by 1. So same thing, principal minus of order. So principal minus of order 2 by 2. Of order 2 by 2. Now 2 by 2 order matrix I want from here 3 by 3. Therefore 1 row, 1 column you have to delete every time. So 1 row, 1 column. So start with first. Okay. Start with first. So first row, first column I am deleting. First row, first column I'm deleting like this. Then this is a matrix. So here the representation is second order principal minor P2. I'm denoting with P2. Now what is that? A22, A23, A32, A33. Okay. Next possibility, you delete second row and second column. So second row and second column I want to delete. So second row and second column I want to delete. Then what is left? That you write here. So determinant of A11, A11, A13, right? A31. So this is 31 here. Okay? A31, A31, A33. Next, any other possibility? Go with the third row and third column. So now delete third row and third column. So third row and third column I'm deleting. Then this is a 2 by 2 matrix. So this is second order principal minor. So A11, A12, A21, A22. That's it. Only 3 principal minors of order 2 by 2. Similarly, next one, principal minors of order 3 by 3. Is nothing but the original matrix. Principal minor of order 3 by 3. 3 by 3. So how many? So 3 by 3 I want, but given matrix is of order 3 by 3 only, indirectly entire matrix will be the third order principal minor. So P3 now. So determinant of P3, that means the 3 by 3 third order principal minus. So is nothing but given matrix A only, entire matrix. Is nothing but det of the matrix A, A11, A12, A13, next A21, A22, A23, okay, next A31, A32, A33, like this. So let us do the problem, same problem what we discussed in the last lecture number 13, problem number 8. Again I want to do, find the nature of the quadratic form associated with this matrix. Okay, so according to this concept, determined concept, I have to find the nature of this quadratic form. So now let us find the nature. Okay, yes. So let us look at the leading principal minus first. Okay, leading principal minus means first you have to look at this one, after that this one, then after that the entire matrix like this. Okay, so first D1, right? So 1 by 1 principal minor, leading principal minor, that is determinant of 2 is 2 only. Next D2, second order leading principal minor, that is 2 0 0 4. Okay, now you are getting 8. Next D3, 3 by 3 principal minor is nothing but given matrix, entire matrix. I assume this matrix A. So if this is A, I need to write determinant of A. So this is nothing but 2 into, let us find the entire det. 6 4s are 24 minus 16, okay, and minus 0 into this finite is 0, and plus 2 into 2 into 4 into 0 0 minus 8, 0 minus 8. So what are you getting? 8 4 16 minus 16. So this is 16 minus 16. So you will get 0. So therefore condition is not verifying. If all leading principal minors are more than 0, then it is positive definite. If all the leading principal minors are less than 0, it is negative definite. If any of the non-zero decay, if any of the non-zero decay disturb the above sign pattern, then it is indefinite. But first three conditions are not satisfying. Look at D3 is 0, it is 0 determinant, it is not non-zero. This is disturbing actually. If it is positive, then all the leading principal minors are more than 0, therefore this is positive definite. Okay, but because of this D3, it is getting 0, it is disturbing. But if it is a non-zero decay, like this non-zero decay, and this is disturbs the pattern. Therefore the given quadratic form is indefinite, but it is I'm getting 0. Therefore first three statements will not work out. Then go to the all principal minus concept, third and fourth and fifth statement. Now look at all principal, only principal minus you have to look at. First principal minus. So first one by one principal minus. So this is not working out. Okay. Then go to the first order principal minor P1. What is that? 2, which is nothing but A11, right? A11, which is determinant of 2 more than 0. Next A22, which is nothing but determinant of 4, which is 4, determinant of 4 is 4, 0, more than 0. Next determinant of A33, now determinant of 6, which is 6, which is more than 0. Okay. Next principal minor of order 2 by 2 you have to get 2 by 2. Every time one row one column you have to delete. So first starting with the 2004 I am taking 2004. Then what is the depth of this? So it is 8 more than 0. Next 2 by 2 principal minor. Next 2 by 2. So by deleting this third row third column I'm getting this. Next second row second column I delete. Second row second column 2622. So let me write here 2622. 26, here 2, here is 2. Now what is the date now? 12 minus 4, which is 8, which is more than 0. Next possibility by deleting first row and first column 4, 4, 4, 6. Okay. What is this? 24 minus 16. So now this is 8, again more than 0. Next 3 by 3. So now 3 by 3 principal minor is nothing but given matrix A. The given matrix is A. Now what is the debt? 2 into already we computed. This is the debt. What is this? I am getting 0. So 2. So directly I am writing 0. Okay. So therefore fourth condition is satisfying. So indirectly what I am getting? Determinant of Pk is more than or equal to 0 I am getting. So therefore the quadratic form, by fourth statement I am concluding the quadratic form is positive. Okay, positive semi-definite. So this is a conclusion. Okay, so do the changes. Only diagonal entries we have to take as a one by one principal minus. Okay, this is a change. Next one. Now today class, the new concept rank, index and signature of a quadratic form. Let's have the definitions first. Rank definition. The number of non-zero eigenvalues of matrix A associated with a quadratic form is said to be rank. Number of non-zero eigenvalues. Okay, that is called rank. Next, index definition. The number of positive eigenvalues of a matrix A associated with a quadratic form is said to be index of the quadratic form. Okay. Next one, signature definition. The difference between positive eigenvalues and negative eigenvalues of a matrix A associated with the quadratic form is said to be signature of the quadratic form. So these three definitions are revolving around eigenvalues only. So the quadratic form is given. First we need to construct the associated matrix A, then find the eigenvalues, what type of eigenvalues is existing. Accordingly we can define what is the rank, what is the index and what is the signature of the quadratic form. So it is about only eigenvalues. Now let us go to the problem about these three definitions. Find the rank, index and signature of the quadratic form. Now let us start. Now find the rank index and signature. So first you write the matrix A. Okay, so matrix A is directly I am writing. Quadratic form is given. So in general, so how many variables are there here? X, Y, Z. Three variables are there in this quadratic expression, quadratic form. So therefore it is 3 by 3 matrix quadratic form. So 3 by 3 matrix. So three variables X, Y, Z, three variables. So let us call X variable is first variable, Y is second variable, Z is third variable. Okay. Now A11 means what? A11 is nothing but in general X1 into X1, right? Because index 1 you will get 1, 1, 1, 1. But here what is first variable? X only. X into X, that nothing but X square. So A11 is nothing but X square coefficient here. Okay. So X square coefficient is minus 9. So therefore A11 is minus 9. So minus 9. Okay. Next A22, again same story. A22 means x2 into x2, right? X2 into x2, like this, because 2 to index 2 to you have to remember. X2 is nothing but second variable. What is second variable here? Y. So y into y is nothing but y square. So A22 is nothing but y square coefficient here. So y square coefficient is A22. So A22 is 3. Similarly A33 is 7. Okay, it is 7. Correct. Next, over. Now these three are over. So this is over, this one over, and this one over. Next, minus 4 into xy. X is first variable, y is second variable. 1 2. A12 is nothing but, right? A12 or A21. So therefore, what I can write? A12 plus A21. Okay, this is nothing but which coefficient? X12, x1 into x2 plus A21, x2 into x1. But what is x1? First variable x, second variable y, x into y or y into x. X into y, y into x. Y into x is not again x into y. Understand? So x into y coefficient will be the A12 plus A21. So x into y coefficient will be A12 plus A21. So therefore here A12 plus A21 will be how much? Minus 4 xy. First variable into second variable. First variable is x, second variable is y. So first variable into second variable coefficient is nothing but A12 plus A21. What is that? Minus 4. So minus 4. So sum of these two entries is minus 4. Then split equally. So minus 2 and minus 2. Okay. Next one. YZ. Y is which variable? Second variable. Z is third variable. So A23 now. A23 plus A32. This is nothing but YZ coefficient, right? Second variable is Y, third variable is Z. Now what is YZ coefficient now? 12. So A23. So this entry and A32 and this entry. So these two entries are how much? 12. So 6 and 6 you take. Split equally. Next one is XZ. XZ is there. What is XZ? X is first variable, Z is third variable. So 1 3. So A13 plus A31 is nothing but this is XZ coefficient. What is XZ coefficient? What is XZ coefficient here? Minus 12. So A13 means this entry, A13 first row and third column entry, A31 third row and first column entry. Sum of these two entries are how much? Minus 12. So this will be minus 6. So this will be minus 6 and minus 6 like this. Minus 6, minus 6, minus 2. Now over. So this is the associated matrix, 3 by 3 matrix. Now for this matrix we need to calculate what are the eigenvalues and what are the eigenvalues. That's it. And look at moreover, this is symmetric matrix. Look at minus 9, minus 2, minus 6 and minus 9, minus 2, minus 6. And minus 2, 3, 6, minus 2, 3, 6. Minus 6, 6, 7, minus 6, 6, 7. And such a matrix is unique. Now let us compute what are the eigenvalues. So now assume the matrix A. So let me write again the matrix A minus lambda I. Let me write. So characteristic equation I want. So A minus lambda I this is equivalent to what is matrix A? Minus 9, minus 2, minus 6. Minus 9, minus 2, minus 6. So minus 2, minus 6, because it is symmetric matrix. Okay. And minus 2, 3, 6. Minus 2, 3, 6. So minus 2, 3, 6. Next one, 7. And this is 7. So this is matrix A. Okay. This is matrix A minus lambda into I. I means 3 by 3 matrix octet. So 1, 0, 0 and 0, 1, 0 and 0, 0, 1. Okay. So now you find out eigenvalues. So directly I am writing because you know how to compute eigenvalues. So direct eigenvalues are minus 1, minus 1 and 3 are the eigenvalues. Compute this are the eigenvalues. Take it exercise. Eigenvalues. So therefore, let me write lambda 1 is minus 1, lambda 2 is minus 1 and lambda 3 is 3. Right? Now let us find the rank first. First, what is the rank? What is the rank now? Rank is nothing but number of non-zero eigenvalues. So what is the number of non-zero eigenvalues here? So all three are non-zero eigenvalues. Therefore, rank is rank of the quadratic form is how much? 3, because number of non-zero eigenvalues are 3. Next, similarly, what is the next question? Index I want. What is the index? Number of positive eigenvalues, right? So index next. Next heading index. Now what is index? Number of positive eigenvalues. What is the number of positive eigenvalues here? So therefore, index of the quadratic form. Index of the quadratic form is positive eigenvalues are how many? Only 1. So therefore, only 1. Positive eigenvalue only. Therefore, index is 1. Similarly, next one. Rank, index and signature I want. What is signature now? The difference between positive eigenvalues and negative eigenvalues. So next heading is signature. Okay. What is signature now? Difference between positive eigenvalues and negative eigenvalues. This is signature, right? Now positive eigenvalues I want. How many positive eigenvalues? Only 1, right? Okay. Negative eigenvalues. Negative eigenvalues is how many? 2. Total 2 negative values, minus 1 and minus 1. Okay. So finally, therefore, final conclusion is therefore signature of the quadratic form is positive eigenvalue is 1, negative value is 2, so which is minus 1. So therefore signature is minus 1. So this is about rank, index and signature of the given quadratic form. The only thing is you need to compute what are the eigen values associated with the matrix, quadratic form associated with the matrix.